Today we're going to start taking a look at factoring by grouping. Okay, so we're still on factoring primarily quadratics, but today we're also going to be taking a look at some other cubic ones because that's really an easier way to teach you guys this new method. Okay, so we need to remember that factoring polynomials is just a method of rewriting a single polynomial as the product of two or more smaller polynomials. We can use grouping to factor polynomials only with an even number of terms, which is really why we got to start off with the cubic ones to show you first, and then we'll show you how you can manipulate a trinomial, which has three or an odd number of terms, to be able to use this factoring by grouping method. So a couple of important things that we need to remember, okay? First off, we always have to look for a GCF before you really get started with the problem. Okay, especially now that things are starting to get larger, we really want to take a look at those GCFs. When we're doing this method of factoring, which is called grouping, and we do it with a quadratic trinomial, we call that split the middle. Okay, or at least that's what I call it. That's not an official mathematical term, but it's a whole lot easier for you guys to remember split the middle when kind of what you're going to do is kind of in its name than saying factoring by grouping, and you kind of have that associated with cubics. But we're going to take a look at how to use this method to go and factor polynomials, right? So like I said, for the beginning, we're actually going to be taking a look at cubic functions. Okay, we know that this is a cubic function because its largest exponent is 3. All right. When we're going and factoring by grouping, okay, what we're really doing is we're trying to find a common factor on half of the polynomial and then another common factor in the other half of the polynomial. So if I look at this one and it's 9x cubed plus 3x squared plus 15x plus 5, I'm just going to go ahead and say left side versus right side. So on the left-hand side, I have this 9x cubed plus 3x squared. What is the greatest common factor between 9x cubed and 3x squared? Well, you should see that 9 and 3, there's at least a 3, and that x cubed and x squared, you have at least an x squared. So let's factor that GCF out of just the left-hand side. So 3x squared, and then what's left over? Well, 9x cubed divided by 3x squared is going to give me just 3x. 3x squared divided by 3x squared is, well, 1. So plus 1. Okay? Over on the other side, I am going to go and do the same thing. But I want to find the greatest common factor of these two terms, 15x and 5. So between 15 and 5, you have a common factor of 5. You don't have any variables that are in common because only 15x has one. So let's go and factor out that positive 5. Okay. And what's left over? Well, 15x divided by 5 is 3x, and 5 divided by 5 is 1. Okay, so what I've done here is I've actually said that I can rewrite this polynomial as 3x squared times 3x plus 1 plus 5 times 3x plus 1. Okay, so I've said that my original polynomial and this polynomial are equal. Okay, now why is that important? Because I now have another GCF. Okay, this is the part that a lot of people tend to kind of struggle with wrapping their heads around. You're kind of always used to thinking that the greatest common factor is always some monomial term. It's 2, it's 3x squared, it's 5. But the GCF is anything that they have in common, okay? And if we go and look at how we've been able to rewrite our polynomial, we can see that we have a 3x plus 1 is a factor of kind of the left-hand side, and 3x plus 1 is also a factor of the right-hand side. So we have a greatest common factor here that is the quantity 3x plus 1. And if that is a factor, well, can't I factor it out? Sure. So we can write this as 3x plus 1. And then what's left over? Well, the leftover parts are this 3x squared and plus 5. So times 3x squared and plus 5. And that, ladies and gentlemen, is factoring by grouping, because we've taken a large 4-term, third-degree polynomial, and we've written it as a product of 2 smaller polynomials. Okay? So we can follow this process anytime that we're going and doing something that involves factoring. Okay? This is called factoring by grouping. So I'm going to go and work through a few more examples. We're going to do these ones a little bit faster so that we can get into the quadratic-y parts, but just kind of follow along because we're trying to make sure that you guys have all this stuff cemented. So the next problem I have is example 2, and it says factor 105y cubed plus 175y squared minus 75y minus 125. So these numbers are an awful lot bigger, but that's going to be pretty okay with me, mostly because I'm just going to be factoring stuff. All right. So to begin, I am going to kind of divide it in half. Okay. So I have a left half and a right half, which is kind of why earlier we said we needed an even number of terms. So I'm going to go and look for the GCF over here between 105 and 175. Okay. Well, is it a number like 5? Probably. Okay. 5. And then we've also got where each term has at least y squared. So if we factor that out, this is going to factor into 5y squared, and I'm going to have 21y plus 35. Okay, and you may notice at this point, wait a minute, 21 is divisible by 7, 35 is divisible by 7. So did I actually get the GCF? Not quite. The GCF in this problem was actually 105, okay? Or sorry, 35. So maybe we go through and say, uh-oh, made a little mistake, but that's okay. It's fine. You can just go and realize learning is all about making mistakes. So 105 and 175 really have a GCF of 35 y squared. Okay, so if we factor out a 35 y squared, well, then what am I going to have left over? Well, I'm going to have just a 3y, and then 175 divided by 35 gives me 5. So plus 5. Okay. Over on the right-hand side, I've got 75 and 125. Okay, so GCF, maybe this time I'll remember to be a little bit more careful and not just think 5. Is there a value that's larger than 5 that's the GCF? Well, yeah, 25. Okay, no variables because negative 125 doesn't have one. Okay, so I'm going to go and say that this is 25. Okay, and what's left over is negative 3y and minus 5. Okay, so there's a very important thing that I'm going to go and show you right now. All right, and that very important thing that I'm going to go and show you is that when we look on the left-hand side of my factors, I have 3y and I have positive 5. When I look on the right-hand side, I have negative 3y and negative 5. So everything is the same, but opposite directions. And that's going to bring us to our next point of something that you should probably remember. Anytime your second group starts with a negative, you should factor out a negative. Anytime your second group, when you're factoring by grouping, begins with a negative, factor out the negative. Okay? Because if I really took a negative 25 out, then this becomes positive 3y, and this becomes positive 5, and then I have terms that match. Okay? So that's just one of the little tips and tricks that we need to remember. So, do I have matching factors that are inside the parentheses? 3y plus 5, 3y plus 5. Guess what? That's one of my factors. So 3y plus 5. What are the other parts? 35y squared minus 25. Okay? 35y squared minus 25. Okay? Is there any more factoring that I can do? Absolutely. Okay, I've got over in the second polynomial, I've got 35y squared and negative 25. I could take a 5 out of each one of those. So I have 3y plus 5 remaining unchanged. Then I can factor out a GCF of 5, and what's left over is 7y squared minus 5. So this is actually the fully factored version of this particular problem. Okay? Now remember that multiplication is commutative. So I could go through and I could put the 5 first, and then the 3y plus 5, and then the 7y squared minus 5, or I could change that order up any way that I wanted to. Okay? You'll also probably notice, hey, we factored out a GCF at the very end. How come we didn't do that at the very beginning? And the answer is, I just kind of started factoring. Can you wait to factor out GCFs until the end? Sure, you probably could. But let's also remember that it's probably going to make it a little bit easier and you're going to have smaller numbers to contend with if you factor out that GCF in the beginning. All right, so let's go take a look at another one. Okay, this one looks weird. But remember, math is really just about applying the things that we already know to new ideas, topics, or problems. All right. So we've got some weirdo polynomial that's 6aw minus 36ak plus 6b squared w minus 36b squared k. All right, well, it's a polynomial, I can tell that much. It's got 4 terms, I can tell that much. So maybe I can try and do something with grouping, okay? But if I look at this problem, first I'm going to say, you know what, I'm pretty sure I can take out a GCF of the whole problem, okay? So if I look at the whole problem, I've got 6, 36, 6, and 36. What do you think I can take out? Probably a 6. So I'm going to take out a 6 from the whole stinking problem. All right. Once I take that 6 out, what do I have left? Well, I just have 1 AW, okay, minus 6AK plus B squared W minus 6B squared K. Okay. And inside of this, that's in parentheses, could I continue to go and try and factor it by grouping? Well, I certainly hope so. What's the GCF between 1AW and negative 6AK? Well, literally just A. Okay, that's my GCF. It's just A. So what's left? W minus 6K. Over on the right-hand side, between B squared W and negative 6b squared k, what's the GCF? Well, b squared. Okay, so a positive b squared. And what do I have left over? Oh ho ho, w minus 6k. So guess what I can do? That's right, ladies and gentlemen, grouping. So we got W minus 6K, we got W minus 6K. So that's the GCF of this whole red thing here. Okay, so we got w minus 6k. All right, and then what's the other part? A plus b squared. Okay, and am I done there? No, because I gotta remember, I also factored out as 6 at the beginning, so I have to include it as a factor at the end. But that, ladies and gentlemen, is going to be what the complete factorization is using complete the square.